is Thomas Domitrovich. And yes, today is Tuesday, and it's time for an IAEI News Live. It is live today. I am at home base, busy as a bumblebee, but I know we all are. So what I want to do is today, I want to focus on separately derived systems. I've gotten a lot of questions since we started our journey through Article 230. I got a lot of questions on interconnected systems, so Article 705. And so I got Article 705, which we are going to hit moving forward. We're going to hit that at some point. We got Article 705, and then I've gotten questions about Yummy Fudge, good morning, about separately derived systems. So let's talk separately derived systems on IAEI News Live, and it all starts now. All right, I am back. Okay, so I just closed something and I said not to save it, so hopefully it wasn't important. Oh boy. Here we go. I'm closing this. All right, let me I gotta bring up the chat. Hey, we got Nihad. All right, so I am going to, how do I break out the chat? How do I break out the chat? I thought I could. Hey, I got you, Nihad. Let me do a copy, and let me do this, Control V. And there it is. All right. All right, David Engelhart in the house. Good afternoon. Step down transformer was not a separately derived system. Ooh, doggy. We're going to have a good discussion today. I love it. Mr. Engelhart. All right, so here we go. Are you ready? The first thing I got to do is bring up the definition. The chat is ready to display messages. Well, that's a good thing. Let's close this. Are we ready? Here we go. Felix Sandoval, good morning. Good afternoon. All that jazz. Here we go. Separately derived system. An electrical power supply output. So what I'm doing is, and I'm showing some slides. I'm in the process of developing slides, Felix, for IAEI. So my thought process is I'm going to use these live sessions to start and continue the development of Nihad and Mrs. El Sharif. Hello there. Hello to Egypt. Great to have you online with Nihad. So you did well in raising that boy. So kudos. I'm very glad to have you a part of the program. So thank you for watching. Thanks for all you do. All right. So separately derived system. An electric power production. Whoop. I've got to make this a little smaller. There we go. There we go. Now we can see it. All right. So that is, there it is. So an electrical power supply output other than a service. So we know it's not a service. And what is a service? A service is constitutes the conductors and equipment connecting the serving utility to the wiring system of the premises served. So we know what a service is. We know a service is the conductors and equipment that connects the serving utility with the premises. So other than a service is a critical piece of the pie. Another very important piece of this puzzle. Hey, anytime we can make mom smile, she is awesome. So I cannot wait to meet your mother in Egypt, Nihad. I know we have some events planned for Egypt, and I'm looking forward to meeting with her and breaking some bread and having a nice meal. All right. Separately derived systems having no direct connection to circuit conductors of any other electrical source other than those established by grounding and bonding connections. So, to the point of David Engelhardt, who made the statement about a transformer. So here is a a transformer, and you can tell I was doing some drawings. So forgive me for my. I'm going to move those off. So here's a transformer. Now, if I think about a delta Y ground transformer, so if I have a delta, and then I have a Y grounded transformer. So I have basically you have, you know what, let's draw it this way. I have a, here's a delta. Let's do this shape. I need a darker background. Let's do this. Home, new slide. Here we go. Control V. So I have a delta primary, and then I have a Y secondary. So, yeah, I can. Let me blow this up. Group, ungroup. So when I have a transformer, like this guy here, so when you have a three-phase transformer, I've got three separate transformers, three separate windings. 1, 2, 3. I've got a bank of three transformers. And remember, I have a core with windings across it. So we sort of draw it here in this diagram. We have three cores, but basically there's air that separates. Ungroup. There is air that separates those. It's going to be a lot of fun. I know, Nihad. We are going to have a blast in Egypt. We're going to have fun. Absolutely. All right, so I have three transformers. Now, any single transformer, I've got a windings on the primary, windings on the secondary, and they are connected via air. The flux that's generated does the transposition. So I have multiple windings on one and multiple windings on another, but there's no direct connection between that primary and secondary. And when I have a delta, so if I have a delta, that means that I am going to be connecting these conductors together like this. Control CV. This is the delta side. Okay, so on the delta side, you have this, and then you have your phase conductors, right? So you come off the center tap of that, and I don't know, we'll color one red, give it a nice thick color, weight. So there's your red. And this would be, say, your blue. I don't know. I'm just going to go for, whoa, can't make it blue. We'll make it like a powder blue. And then we need a connection, Control CV, like this, like that. All right. And I hope I'm doing this justice. And then we would have to take this one out. And we'll call this one black. We'll make it black. All right. So you have phases A, B, and C. That's the delta on the primary. Now, on the secondary, it would be a Y grounded system. So we would be connecting sort of like this. Wow. All right. And let's copy this one down. Now remember, in a Y system, one leg of each transformer they're all connected together. And then these conductors control. Like that. All right. And then this neutral point is grounded. Gotta say, pretty good with the edits on PowerPoint, yummy fudge. Oh man, I'll tell you what, and I'm on the hot seat. I am definitely on the hot seat here. How do I draw a line? I'm going to draw another line, and I'm going to make it this is going to come out, and watch this. I'm going to do there, and I'm going to click that, and then I need to, this is my neutral conductor. So I've got 3 hots, I've got a neutral, and then what we will do is we will say we have to bond this, right? So we would come out, and I'm just going to draw this. I'm going to make it green. I will make it green if you know what I mean. Control CV. And this would be my ground. Oh, here's what I'll do. Watch this. Control C. Control V. And we will bring this puppy like that. And we'll make a connection. Shape. There, 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 there. And we're going to make it green. We're going to make it thick. And we'll bring this to front. Control, Shift, F. There we go. So what we've done is we've showed I have separation. So if I draw a box around this, let's draw a enclosure around my transformer. And we'll make it gray. Send that to the back. And I have to also bond that's all going to be bonded. Right, so basically you have a, let's do this, draw this circle. Oh man, we'll fill that in as green, shape green. Here we go. All right, so I've got my separately derived system. I have a separation, complete separation of the line side of that transformer from the secondary side of that transformer. On the secondary side, I go to ground. I connect it to my grounding electrode system. And I need to close that. Oh man, thanks. My mom. I feel I was educated the individual so I could approve the review. Couldn't forget when transfer switch switches the neutral. Oh, I'm going to hit that one. Steve Cavaleris. Hey, in the house. Thanks for being here, brother. Thomas and everyone. Felix Sandoval. Okay. Transfer was not a separately derived system. Yummy fudge. Good job on the hot seat. Thanks, Laurel in Omaha. Thank you. Is it a grounded or ungrounded delta? That would be oh man, I'm glad you said that, Yummy Fudge. All right. Because I have a delta primary, that doesn't mean my system is not grounded. It's a separately derived system. If I looked at a one-line diagram, let's do this. Let's do this. If I had a one-line diagram and I drew, so I do this, I grab, where's my transformer? I'm going to grab a transformer, Control C, and I'm going to do a Control V. Let's say I have a transformer here, and I'm going to draw a, where's my line? I'm going to make this thicker, and I'm going to make it white. All right, so I have a transformer, Control CV. And let's say that this is a delta Y ground transformer. Delta, boom, no fill. Oh man, how do I draw a Y? I am going to attempt this. Are you ready? Oh, watch this. Here's how I'm going to attempt it. I'm going to do this, bring this down, and we'll spin it around. And we're going to draw some lines. White. Control CV. Connect that to the corner. Control CV. Connect that to that corner. And then we're going to delete. Boom. Delta Y ground. And I'm going to draw my little line here. Control CV. We do that. And we do this. And we do a couple lines. That. And that. All right, so I have a delta Y ground transformer. Now I'll probably supply a panel board. Am I even showing anything? Yeah. All right, so I supply a transformer. I supply a panel board. I'll have a breaker. I'm not going to show the breaker because I'm just going to do single lines because I'm just demonstrating something. Now, Control CV. I can connect another transformer off of that bus. It's not a service. I assume it's on the premises. Delta would be grounded as well, unlike a service. The delta side is not grounded at the transformer, but it is grounded up above. So up here on this system, this panel board is grounded. I only bring 3 conductors to this transformer. I don't need to bring a neutral because there is no neutral, and I would bond everything together. But because I have a delta here, it doesn't mean it's an ungrounded system. What that delta does is, yeah, the Yummy Fudge. The reason I asked is because since it's not a service, I don't know why how do I closing that? Hopefully I didn't close. There we go. Thanks for pointing it out. The reason I asked is because since it's not a service, I assume it's on the premises. I was assuming the delta would be grounded as well, unlike a service. So the deltas, again, the delta on the transformer is not grounded. And I need to do this because I want to see the chats at the same time as we're talking. So for some reason, oh, I know what I'll do. Here we go. All right, I fixed it. Oh, no, I didn't. Give me a break. Give me a second here. I need to make this larger. That way the chat is on the right-hand side, and then I get this on the left-hand side so I can see what the heck I am showing. All right, so there we go. But thanks for pointing this out. All right, so I have a delta Y ground and a delta Y ground. This entire system is grounded. If it was not a grounded system, if it was an ungrounded system, then everything would be deltas. That would be delta, 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 delta. And that would be your ungrounded system. But what this delta does, that isolation, ground faults on the secondary won't flow through the won't flow through the delta on the primary. So ground fault currents, the zero sequence currents, will circulate. A ground fault on the secondary of a transformer looks like a phase-to-phase fault on the primary. So we have, this is our two systems. I'm just going to leave that there for giggles so that we understand the difference. So they're very good. Thanks for, you probably already knew this, but others who are watching this may not know it. But these are separately derived systems. Now, if it was a auto transformer, an auto transformer is not a separately derived system because they share the same winding. But if I have a delta-delta, a Y-to-Y, those configurations are all separately derived systems. Now, the other, so whether this is wired in, this is wired in, this is wired, Control C, Control V, delta Y ground. Now, I can change the configuration, make it a Y-Y, and it's still a separately derived system, right? I have not changed the fact that if I go back to the definition, no direct connection to circuit conductors of any other electric source other than those established by grounding and bonding. So if I come back to this, and if I have a box here, let's draw a box around this transformer. Okay, that'll be a gray box. Not a clear box, but a gray box. Be a dark gray box. Control Shift B. And then I do a Control C and I draw another box here. Control Shift B. Whoop. Control Shift B. Dadgummit. B. Command B. There it is. All right, so I have those. Now, and let's say that this is a panel board. Let's say that this is a panel board, and I'm not showing the breakers, so please forgive me because I'll fill that in later. When we talk about other than those established by grounding and bonding connections, I would have this connected with this, and that would be a green. A nice thick green connection. And then this would be connected with, let me go to shape format. You're going to love this. Ready for this? Edit points. Boom. And then, and then we can't figure out about the other panel board. So we got a panel board down here. And then we have this. And you're going to love this one. Edit points. Bring that there. All right, so all of the bonding, all of these enclosures are bonded together, regardless if it's a separately derived system or not. We can't lose sight of the fact that everything is bonded for to keep everything at the same potential. All right. So I'm just going to do this and draw a Nice green dot. Control CV. These are all connection points. Okay. These are all bonded together. And whether it is a separately derived system or it's not a separately derived system, I don't care, because all of our equipment has to be bonded together. Make sense? So all of our equipment is bonded together, and whether it's a separately derived system or not, that bonding will happen, and that will not impact whether or not it's a separately derived system. Okay, so, hey, Carl Lewis, thank you, sir. Electrical engineers, love you out there. I'm a PE, and I'll tell you what, they don't teach you stuff in school. All right. Okay, so separately derived systems, delta Y ground, delta Y, Y, I don't care. I don't have a connection between the primary and the secondary outside of all of this bonding that's going on. All right. Okay, so, and if I look at my transformer, this is, again, you'll have, oh, that's a good point. Transformer bonding. I know we have some good, we should have some good pictures here. Resources. Let's look at the I'm just going to grab a catalog and see what might if there is a Control F grounding. I'm looking for a good photo of the inside of a transformer, and I thought I had them. Transformer. Let me just look at my photos. Transformer. There's a good one. Where is it? Here we go. Is this? Yeah, I might be able to use this. There we go. Here's a good picture. Well, I wouldn't say it's a great picture. I would say it's a picture. All right. So this is this is what we call a transformer. And let me get my restream. Oh, Michael Hofkin in the house. Hit that like button. Subscribe. All that jazz. So here's a transformer. You can see down here. If I can zoom in. How do I zoom? Create, hide, duplicate, rotate, share, get info. There we go. So there's your windings. All right. Here are your H1 high and H primary and secondary terminations, and there's your look. Here's your diagram: Y delta, so delta on the primary, Y on the secondary, and then this is your bonding strap that occurs inside, and this is the area where you will be connecting your grounding electrode conductor and bonding this secondary side, and your neutral will connect to this as well. All right. You don't never want to. This isn't a training on transformers, but I just want to show you what it looks like and how these things are connected, and how it's all going to be bonded. All right. So non-current. All right. So let's get out of this. I close my images. There we go. And we'll close that picture. All right, so separately derived system. Again, primary and secondary. The wiring of one system is separate from another system outside of the grounding and bonding. Grounding and bonding is going to be very critical in our discussions. Very critical to understand the requirements in this area. Because that's just what separates us, separates the boys from the girls, right here, or from the There we go. So you have the transformer, grounding and bonding, grounding conductor. I mean, these are two separate. If you're not doing that bonding, it's like black and white. It's either black, you're bonding, white, you're not. These are two different types of systems. They're two different things. Separately derived versus non-separately derived. The moment you bond, in this case, in a transformer, you're bonding that's a separately derived system. You're taking your neutral and your grounding, your equipment grounding conductor and your grounding electrode conductor, all of those, and bonding them all together, and then going down to the panel board. You have a supply side bonding jumper where you're running a conductor. This is a flex conductor going to that transformer. That when you're running flex, we can't use the flex as our equipment grounding conductor. So we are running a supply side bonding jumper from the transformer to the panel board. All right. In that case, let's do this. I'm going to go back to, I'm going to close this. I got so many things open. This is the 2023 code. Okay. If I look in Article 250, 250.35a. So grab your code book or get out your NFPA link. 250.35 is speaking to generators. So if I have a generator, like we have here, all right? So if I have a generator, much like a transformer, I am going to make a connection between the ground bar and this neutral bar for a separately derived system. If it's a separately derived system, you have to follow the requirements in 250.30, which is called, I'm trying to work off of a small screen, 250.30. Jeez, oh man. Grounding separately derived alternating current systems. So this is where you are going to follow grounded systems, separately derived AC systems that's grounded shall comply with A1 through A8. A1 is your system bonding jumper. Unspliced system bonding jumper shall comply with 8A through D. Connection has to be made at any single point on the separately derived system from the source to the first system disconnecting means, which this is my source. There's my disconnecting means. Whoa, what happened? There we go. All right, I'm back. No disconnecting means or overcurrent devices in accordance with blah, 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 blah. The system bonding jumper shall remain with the enclosure. So it says I'm reading in A1, system bonding jumper. Unspliced system bonding jumper shall comply with 250.28A through D. It has to be made at any single point on a separately derived system from the source, which is the generator, to the first disconnecting means or overcurrent device, which is the generator breaker, or it has to be made at the source of a separately derived system that has no disconnecting means or overcurrent device. So if I didn't have a disconnecting means on that generator and I had a separate disconnect, then I would be providing that jumper that goes over to that first disconnect. Or overcurrent device in accordance with 250.30A1A, A1B. The system bonding jumper shall remain within the enclosure where it originates. If the source is located outside the building or structure supplied, a system bonding jumper shall be installed at the grounding electrode connection, etc., etc., etc. The system bonding jumper shall connect the grounded conductor to the supply side bonding jumper and the normally non-current carrying metal enclosure. This is all of the bonding that we're doing right here. Installed at the first disconnect, the system bonding jumper shall connect the grounded conductor to the supply side bonding jumper, the disconnecting means and enclosure, and the equipment grounding conductors. Then you have a supply side bonding jumper, which we saw a picture of that in this image here, we had a supply side bonding jumper being provided from this transformer enclosure to that panel board, and that's maintaining that connection from the grounding electrode and grounding electrode conductor to the ground bar that's in the that first panel board. The supply side bonding jumper shall be permitted to be of non-flexible metal raceway type or of the wire or bus type. So this is a wire or bus type. If I have rigid metal conduit, then I can make that my equipment, my bonding jumper, right? My supply side bonding jumper. Grounded conductor. If a grounded conductor is installed and the system, let me look at I'm going to look at my comments. I'm not reading my comments. 250.30, the informational note under 250.30 might be interesting. 250.30. An alternating AC power source, such as an on-site generator, is not a separately if the grounded conductor. There we go. A very good point. Okay, informational note number 1 is, it says an alternate AC power source, which might be a generator, such as an on-site generator, is not a separately derived system if the grounded conductor is solidly interconnected to a service-supplied system. Grounded conductor. An example of such a situation is if the alternate source transfer equipment does not include a switching action in the grounded conductor that allows it to remain solid. So, let me show you what we're talking about there. I'm going to see if I can put this in presentation mode. Can I? Where is my... There we go. All right. So, I need to fix my display. Bear with me. Are you bearing with me? I am going to try to describe this. Okay, so now I have a corner grounded delta utility transformer. I know Nihad, you had that comment once before, but let's just draw the parts. I've got a utility transformer. I have a transfer switch that is suitable for use as service equipment. And then I have a generator that is bonded. So very similar to the previous drawing, I have my neutral and I have my ground bar and I have that jumper in place. You may go to some utility applications that, or I'm sorry, you may go to some generators that do not have the bond in place. I'm just going to try to get both of these things up at the same time. Sorry about that. Jeez, oh man. Carl Lewis, they really don't teach the NEC in engineering school, graduated in 2019. Yep, I graduated in 1990, and they didn't teach the NEC back then. Nothing has changed. All right, so now this is, let's just look at this diagram because there's a lot going on right here. I've got over on the closest to me here, I've got a generator that is bonded where the neutral is to the ground bar inside that, which is bonded to the enclosure, right? So that's what this little green nub is right there. It's bonded to the enclosure. That's in the generator. That's all self-contained in the generator. I have a breaker inside that generator as well. That red line that's here represents 3 phases. It just gets too busy if you're going to draw 3 separate lines. In the transfer switch, you'll notice my main bonding jumper. This is service equipment now, so it's suitable for use as service equipment. I'm going to bond my neutral bar and my ground bar in that equipment. I have a service disconnecting means. I am switching the neutral in this case, and that's the white conductor that has, can I do this? Oh, laser pointer. I can do a laser pointer right here. Can you see the laser pointer? That is my switched neutral. These are my switched hot conductors, and there's 3 in there. I've only drawn 1. All right. Let me get rid of the laser pointer because I need to flip. Okay, so when I connect the utility to, I have the red line is my 3 phases connected to the service disconnecting means, the 230/62 requirement, and we just went over all services. So Article 230, we had like 3 sessions on services. Those are service conductors that go from the point of service, the point of connection to the utility, whatever that line of demarcation. In this case, I'm showing it in the transformer. You know, I just picked a spot. So I'm connecting that transformer to my service overcurrent device, which is in my transfer switch. I am 250.24c requires me to pull a grounded conductor to my service equipment, which in this case is this transfer switch. That's a grounded conductor. You'll notice it's bonded over there in the transformer. It's bonded in here, and all of that is grounded. So I bring that equipment over. I bring my 3, and that's what's going to connect my 2 together. All right. So then, because I'm going to switch the neutral, my neutral is really all bonded at this point. So I'm going to come off of that neutral bar, and I'm going to go straight into a disconnect, a transfer, right? So that when I'm on the utility, I'm connected that neutral to the utility transformer. But when I'm not on the utility, I'm going to feed it from the generator. And we're going to walk through this to help you get this, all right? So that's, and your reference there, that's standard service equipment. So go to Article 230 and it'll show you need to bond those 2 together. So now I'm going to pull in my feeder. It's a feeder from the generator. That's not a service. Remember, a service is defined and it's related to a utility. That is not a service. That is a feeder. I'm bringing my bare copper conductor over. Now I could use raceway, right? If I do if I used my rigid metal conduit, RMC, that could be my bond that's occurring between the 2. I bring my hot conductors and I bring my neutral, and you'll notice I landed the neutral from the generator, the grounded conductor from the generator. I landed that on the other pole of the transfer switch, right in here, okay? Wish I had a nice big pointer. I'll have to figure that one out. Ooh, I know if I shake this, it gets bigger. Look at that. All right, so it's right there. If I just do that, that's bonded there. Now, when I'm supplying from the utility, my ground reference, my grounding electrode conductor, all of that is bonded at this equipment, and it's all connected together through the main bonding jumper. My grounding electrode connection for the grounded conductor is handled right there at that service equipment. When I switch over to the generator, now my grounded conductor is not connected to the grounding electrode that is pulled into this service equipment. It's connected to the grounding electrode and the bonding that is occurring over in the generator. So, capiche? Does that make sense? So, when I have a separately derived system in that generator, I have to switch that neutral because I'm bonding in the generator. I'm bonding the grounded, the neutral of that Y generator, the neutral of that with the equipment, with the grounding electrode conductor, which is terminated to the grounding electrode system. 250.35a is your reference for all of that. So I hope that's the right reference, 250.35a. So I have it, if I have the transfer switch which switches that pole, now I am not connected to the transformer on, you know what I didn't do? Hold on. I got it. Boom. I forgot to do that. Right? So you'll notice, let me do this. I'm gonna draw. You ready? I'm gonna do a highlighter. I can highlight. So all of this is my utility side. All of this, when I'm on the generator, I have no connection because I have switched the hot conductor 2. So my generator is now independent from the utility, both on the ungrounded conductors and on the grounded conductor. Because of this separation right in here, I am separate from the utility grounded system on my normal source. So all of that is separate. So I've met the definition of what a separately derived system is. And if you recall what that is, let's do this. I am going to, how do I do this? Escape. I am going to exit. I'm going to discard all of those. If I go to my defined term, let's take a look at that. An electrical power supply output other than a service having no direct connections to circuit conductors of any other electrical source. So if you remember in that diagram, where's it at? Here it is. I am completely separated from this other source, which is the utility source. My red, my phase conductors, I am switched over to the generator. My grounded conductor, I am switched over to the generator. The only thing I'm using this transfer switch for is to supply power from the generator. I'm bonded with the equipment grounding conductor. I am bonded to the enclosure of the transfer switch. And I'm showing a conductor. I could be grounding through rigid metal conduit, RMC. All right? Yummy fudge, that is so important. Why I mentioned that an informational note, and I'm glad to see you had such a, well, yes, excellent. Yummy fudge. So this is a very important piece of the puzzle when you're dealing with a generator that is a separately derived system. Now, let's say, for example, let's do this, yummy fudge. Let's find a drawing. Let's do this. Let's say, for giggles, Control C, Control V. Let's say that I am a non-separately derived system. Well, let's do this. Let's say we did this. I'm gonna edit these points. And I'm going to pull this over here. And I'm going to get rid of this, of this, of this. I'm going to make this connection right like this. Now what I'm doing is I am not switching the neutral. Okay? I am not switching the neutral. Make that thick and give it a bevel. Now I'm not switching the neutral, I'm only switching the phase conductors. So Fred, your picture still has utility neutral and grounding electrodes still connected even though you switched the, yes. Yep, that's fine. That's all. That is all perfectly fine in that other picture, Fred. I'll go back to that. But what I'm doing now is I'm going to say this is bonded. I do not switch the neutral. So now I have service entrance equipment. I'm bonding here. I'm not switching the neutral. This is all connected. When I'm running off the generator, if I did this and I switched to the generator, now I am bonded here with that neutral, and I'm bonded here with this neutral, the grounded conductor. The grounded conductor is bonded at both locations. I don't want that. You don't want that to be the case. So you have a choice, right? And you could say, look, what you need to do is buy a new transfer switch. You need to go buy a 4-pole transfer switch. And I would say, no, you don't have to buy a 4-pole transfer switch. You don't have to replace the transfer switch. All you need to do is go into the generator and do this. Delete. You delete the connection between the grounded conductor, this neutral conductor, and that ground bar. And now it's a non-separately derived system. And if you go to the instructions on a generator, you will probably see, I know you will definitely see instructions that tell you that that's all you have to do. So if you bought a 3-pole transfer switch in this case, and you're the inspector, or you're looking at it from an inspection perspective, or you're the design engineer, or you're the installer, let's do that, and say you set the generator and you see this bond, and you know you only have 3-pole transfer switch. All you got to do is delete that bond in the generator. That separates the neutral conductor from the equipment grounding and bonding. You don't need, now you may say, well, I drove a rod and everything. Well, yep, you drove a rod. You can leave the rod there. There's nothing that prohibits you from having a rod, grounding electrode conductor and a grounding rod and all that good stuff. There's nothing that prohibits that. You don't need it. So what you could do as well is delete that and delete that. And now you still have a code compliant application. Laurel, yes, 110.3b, manufacturer's instructions. In fact, generate. I thought I had, let me look. I might have generator. Let me look at something here. I might have a transfer switch. I know that I had a long time ago, I did an inspection with, an electrical inspector. And we went to a job site, and sure enough, we found that they had bonded inside the generator. Places. Let me go to places. They bonded in the generator, and they only had a 3-pole transfer switch. It was right near my house, too. I'm going to see if I still have those photos. And I thought I took pictures of inside the generator. And I am not finding those photos. I'll bet you I deleted them and moved them into a different folder. But in any case, I pulled the instructions for the generator, and I believe it was a Kohler generator. Let me do type, kind, and presentation. And in the in the instructions for that generator, there was in the installation instructions, there was dialogue that said to disconnect the bond between the two conductors. And I'm looking to see if I have a picture of those. And I am not fine. Oh man, here's it. Is this it? So I'm just looking at the, I'll show you what I'm looking at so we can look at it together. This is inside your generator connection. So this one says for standby service, neutral, floating, maximum load. I'm looking for the diagram, and I thought I had a good picture of the instructions, but I don't see them. No, I do not see them. All right, but if you look at the instructions for these types of applications for the generator, it'll tell you exactly where you need to disconnect that bond inside the generator. You don't need to go buy a brand new transfer switch. Just make sure that you separate that, and you're not switching the neutral, so you're still bonded, you're still grounded to the grounding electrode system, the whole jazz. You're just switching the hot conductors or your ungrounded conductors. All right, so your separately derived eliminate dirty neutral from the utility when in general power, but if the utility side is still connected, that is not truly disconnected when. So here's the thing, Fred. Let's take a look at this. I want to make sure that I get my comments up. All right, so in this switched system, okay, when you're on the normal side, you are connected to this grounded conductor coming from the utility. When I'm on the generator side, my grounded conductor, so I see what you're saying. Well, no, my grounded conductor, yeah, it is. You're saying that because of, I'm going to use my highlighter again, Freddie B. You're saying because of this connection right here, go into this goes to that, and that goes to this. That's, I think, what you're talking about. All right, Yummy Fudge. Thank you for joining in. Is that what you're talking about, Fred? Yeah, I see what you're saying. I see, Grasshopper. Here's how you fix that, Fred. Let me show you how you fix that. I'm going to do this. I'm going to take this diagram. I'm going to move this down to here. And I'm going to delete this. Boom. 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 I'm still legal. I am still legal because here's what I need to do. Man, no matter what, Fred, I'm still, I still have issues, right? I see where you're coming from. I'm catching what you're throwing. I am catching what you're throwing. You're right. The enclosure is still bonded. And when I throw that neutral, when I switch over, you still have that bond, and then through the enclosure to that. Yeah. Your enclosure is still bonded. You're not completely, it's through the bonding, you are connected, which is permitted for a separately derived system. You're permitted to connect through the bonding, but your grounded conductor is separate, your ungrounded conductor is separate. Your bonding is not. Your bonding is all there. But your grounded and your ungrounded conductors are separated. So and then that's a good point, Fred. Your enclosure is still bonded. But that's the gist of a separately derived system. And I can't believe did we blow through an hour already? Holy crap. We did. We blew through an hour. Well, you got some code references. We talked about the philosophies. We talked about what's a feeder, what's a service. We showed the 4-pole versus a 3-pole. We showed the bonding of that grounded conductor. We showed how you need to, we talked about the transformer. We talked about the generator and the bonding that has to go on in the generator if it's a separately derived, and to just simply undo that bond if it's non-separately derived. So I think we covered a lot of ground for an hour. And Fred, I appreciate you dialing in. I cannot believe that hour went that fast, but it did. And I thank everybody for dialing in. Don't forget to hit the like button, smash the like, hit the subscribe. Would an isolating transfer fix his issue? I'd have to do more homework on that one, Fred. I would have to do a lot more homework on that one. Thank you, Felix. And it was a good compliment to the services. And Fred, I'm going to do some more homework for your question. We still have to get into 705, Article 705, specifically 705.11 and 12 for those interconnected systems. I'd like to hit 705.11. It's a point of discussion going on right now. So, all right. Well, hopefully we got something out of today. I know I did. I was a good discussion, and Fred, you did not. Robert, always remember that return current is trying to get back to the source of power. That's true. It's trying to get back to the source, which is the generator, not the utility. But I think, Fred, I'm going to I'm going to do some more thinking about your question. Very good question. All right, everybody. I have things to do, places to go, people to see. I appreciate everybody's attention. Thank you for everything that you guys and gals do for electrical safety, the electrical industry. Thanks for dialing in to today's session. If you have any questions, please don't forget, just send them into IAEI. I know it'll find its way to me. I'd love to hear your questions, ideas for future editions. Niad, thank you. And your mom is awesome. I can't believe she sat through all of that, and I thank her as well. And one of these days, we're going to do dinner together and break some bread, and you're going to teach me how to speak Egyptian, or how to speak, not Egyptian. Oh my goodness. It's the most widely used language. Anyway, Laurel, thank you. Take care, everybody. Good night. Stay safe. And please, by all means, stay healthy. And Jake says hey, too. Thanks, Steve. Take care. Good night.